For the last few years, we've treated AI like a very smart encyclopedia. You ask a question, you get an answer, and you ask another. That entire model of interaction is dead. The limitation of conversational AI is that it requires a human operator at the wheel. It waits for your prompt, generates text, and stops. It doesn't actually execute workflows on its own. Between April 26th and 27th, 2026, the technology industry publicly abandoned that model. In a single 24-hour window, researchers, developers, and hardware giants pivoted to a new baseline. This flowchart shows the architecture of Agentic AI. Instead of waiting for the next prompt, an agent takes a high-level goal, maps out a multi-step plan, opens software interfaces to take action, and self-verifies its work until the job is done. If you ask a chatbot to fix a bug in your code, it gives you a text snippet. Give that same task to an agent, and it opens your developer environment, writes the code, runs tests, finds its own errors, and commits the final version while you are away from Woodesk. The static prompt and response loop is obsolete infrastructure. Making autonomous digital workers a reality required 3 simultaneous breakthroughs across software, economics, and physical hardware, all arriving in a single day. OpenAI released GPT-5.5, internally codenamed Spud, as a completely new pre-trained base model. They built this foundation from the first token to bypass the limitations of post-training tweaks or distillation. This fresh architecture provides strong native reasoning. It inherently understands how to take a complex objective and break it down into a logical sequence of actionable steps before any specialized training is applied. It can navigate desktop environments, can execute code, and control external software interfaces. It clicks, types, and browses exactly the way a human user does. This chart shows performance on the OS World Verified benchmark, an environment testing autonomous computer operation. GPT-5.5 hits an almost 79% success rate, completely separating itself from the cluster of previous models. By mastering this core reasoning layer, OpenAI built the logic engine required to move past simple task delegation and execute complex job completion. But a logic engine this capable introduces a severe limitation. Running thousands of high-end OpenAI agents simultaneously requires immense computing power, pricing out almost every enterprise outside of the tech giants. That bottleneck cracked immediately with the arrival of DeepSeek v4. Built as an open-source alternative, it is co-optimized for Chinese sovereign silicon, allowing developers to bypass Western export controls and expensive hardware entirely. It features a 1 million token context window, meaning the agent can hold vast amounts of information in its working memory at once. It retains the full history of a long, complex task without forgetting the initial instructions. This graph tracks the API cost per million output tokens. While OpenAI's flagship model hovers around $30, DeepSeek v4 Flash drops that cost down to 28 cents. That is a 99% price collapse. Slashing the compute cost transforms autonomous AI from a luxury enterprise experiment into an infinitely scalable, cheap commodity that any developer can deploy. A digital worker running continuous, self-correcting loops consumes between 20 and 50 times more computing tokens than a passive chatbot. That volume breaks standard data center architecture. To handle this massive load, Google used their Cloud Next event to reveal a literal fracturing of their data center architecture, rolling out a specialized 2-pronged chip setup. This diagram illustrates the new hardware split. The TPU-8T is a brute force powerhouse optimized for training trillion-parameter models and generating synthetic data. The TPU-8i is optimized purely for low-latency inference, stringing together millions of concurrent agent loops to keep the workforce running. Maintaining stateful digital workers over long durations requires a hardware focus on memory hierarchy and interconnect efficiency rather than raw flops. Over 24 hours, the necessary pieces locked into place. Software solved the logic, open-source models solved the pricing, and fractured hardware solved the physics. Now the industry faces a new primary constraint, known as the inference tax. This is the massive, sustained energy cost required to let fleets of agents operate independently in the background, around the clock. Supporting these automated fleets requires specialized infrastructure, driving projections for a rapid spike in custom silicon manufacturing to handle the continuous computational load. Letting these systems run loose introduces immediate risks. When an autonomous agent makes a catastrophic error, the liability is completely undefined. We're also facing the danger of self-improving loops operating faster than human oversight can track. These models are now hitting 84.9% accuracy on benchmarks, covering 44 different occupations. They are increasingly capable of handling the multi-step workflows typically assigned to entry-level knowledge roles. The industry is now focused on orchestrating vast fleets of these agents, prioritizing the safe and cost-effective management of a digital workforce at scale.